Hello and Assalamu alaikum. This is Ali Abbas and I'm here with my new video about factorization, and in this specific topic I'm going to discuss about the factorization through algebraic identities. So first of all, remember all of these three identities in the basics of algebra. Like the first one is a plus b whole squared equals to a squared plus 2ab plus b squared. And the second one is a minus b whole squared equals to a squared minus 2ab and then plus b squared. And the third one is a plus b times a minus b equals to a squared minus b squared. First of all, try to understand which one of these you can say terms in the equations are the factorized forms and which one of them are the expanded forms. So try to understand when the terms are going to multiply with each other means the complete terms. When there is a whole square, it means that a plus b will be going to multiply with a plus b itself. That will be factors of a plus b whole square. Means when two terms are going to multiply, it means that those two numbers are the factors of the complete whole term. Similarly, a minus b whole squared can be written as a minus b times a minus b whole squared, means number is multiplied by itself again. So this is also the factorized form. So the last one, as you can see, when the b terms are having different signs, so it will definitely tell us the factorized form. So the right one of all of these equations are the expanded forms, which are expanded in which the brackets are opened and simplified further. So the right side terms are basically termed as the expanded forms. I'm just writing down for your understanding. And the left hand side terms are basically known as the factorized forms. So once the question is asked for the factorization, so in that case, we have to convert the right-hand side expanded forms into the factorized forms that are on the left-hand side of this, I can say all of these three equations. So in the very first question, you can see factorize. In factorization, when we are going to apply these identities, this is the thing I want you to understand and look at this clearly, and then you will understand it quite easily. Just look at the identities in in which of the three identities there are three terms in the expanded form. You can clearly see in the third identity there are just two terms, and in the first and second terms there are first and the second equations there are three terms. So as you can see, if there are three terms, look at the first term of the given question and the last term. In this case, a squared and b squared are written in both of the equations. It means that first term and last term both must be square of some number, some variable. So you can see x squared can be written as in the form of x whole squared. It means that x squared is square of x. Similarly, 9 is a perfect square. It is square of 3. We can write down it as 3 squared. So in the center, if there is positive sign, it means that we have to apply the first identity. If there is negative sign, we have to apply the second identity. But look at the terms, whether the midterm is proving 2ab thing. In both of the cases, there are 2ab in the center. If it is proving ab, then we can apply. Otherwise, we can't apply this thing. So we are going to check. So write down plus here. 2 times a is the term which is under the square, that is x. Similarly, b is 3. So 2 times x is 2x times 3 is 6x. It means that it's going to prove this thing, the given question. So we can write down in the form of the left hand side equation, it will be first one, because midterm was positive, so it was satisfying plus 2ab. So it will be a and plus a is x and plus b is 3 and whole squared. This is a factorization of the given question. So I'm going to solve one other type of question that involves this first type of equation, but in that case, what exactly is given, we can just look at the question. If it is 2x squared and there is sign of plus, and we can say it is 8 plus 8. We have to do factorization. The process is same. We have to do factorization. We can see there are three terms, but first term and last terms are not squared. So there are some other rules for factorization as well. First of all, look at the given terms. In factorization, there is very basic rule. If there is something common in the complete expression, we can take it common. Okay, from the complete. Okay, if there is something common in two terms like 2x squared and 8x, you're going to take x common and 2. That will not be fine. So this must be common from the complete expression. So 2, 8 and 8, what's common? So 2 will be taken as common, right on the bracket, write an x squared, and then plus 2. How many times makes 8? It will be 2 4 times, again plus, and 2 4 times is 8. Now look at the terms inside that bracket. So x squared is square of x, and the last term is square of 2. It means that we have to apply the first identity because in the center there is a positive sign. So 2 will be written till end. 2 will be written till end for having the complete factorization. So x squared can be written as x whole squared and plus 2 squared will be satisfying for 4. In the midterm, it must be having 2 times a. A will be x and b will be 2. It's satisfying 4x? Yes, perfect. So in the last step, we can write down it as 2 and times a is x plus b is 2 whole squared. So 2 times x plus 2 whole squared will be the final result. So we have done two of the specific types of questions that will come from part 1. So what about part 2? In part 2, in second type of questions, in that type of questions, there must be negative sign in the midterm. So I'm writing down the third type of question in which we can see that 9x squared minus 24x and plus 16. So in that specific case, if you can see 9 and 24, there is something common, but not from 16. Means the highest common factor of all of them is 1. So we can't take anything common from here. So just look at the second equation. It's same like the same process we're done in the first part of the first question. And second question, we have to check whether first term is square of anything and last term is square of anything, then we can simplify it further. So 9 is square of 3. So I'm writing down 3 and x square is square of x. Write down in the brackets. And 16 is square of 4. So write down 16 as 4 squared. So negative sign will be written as it is. And 2ab, we have to prove it. Okay, we have to write down 2ab. So 2 times a is 3x. And what about b? B must be 4. So whether it's giving 24 or not, 2 times 3 is 6, times 4 is 24. Yes, it's proved. So we can write down the final step. It will be a. A will be 3x and minus b will be 4. So this is the answer for the third question. So we are moving ahead to the fourth type of question. I'm looking at the question in which there is something common from the complete term for the second type of the algebraic identity. So it can be 3x squared minus it can be 18x plus 27. So look at this specific expression, whether something is common in this complete expression, you need to take it common. So we can see the highest common factor of all of them is 3. So 3 must be taken as common. X squared is left. Minus 3, how many times makes 18? It will be 3. 6 times and plus 9 will be written as it is. So 3 will be written till end. So x squared is square of x. And then minus we have to prove to AB here. So it will be 2 times x. What will be b? B will be 9 is perfect square of 3. So we have to write down like this. And b will be 3. So it's proved. 2 times 3 is 6. And x will be multiplied. It will be 6x. So what's the final step of it? The final step of it will be 3 and multiplied with x and minus 3 whole squared. So this is the fourth type of the question. It means for the second identity, whether something is common, we need to take it common in the first step. Otherwise, we will be having problems at the end if we do with some other type of method as well. We can apply it, but the end process must be done as well in that case. I will just, I can say, give you the explanations in some other video about other types of factorization. I was talking about midterm break. We will do later on. So moving ahead to the last type of identity in which there are two terms which are given and we have to factorize. These two terms are, these two must be square of something, and in between there must be a negative sign. So you can see there is a negative sign. There are two terms that apply the third identity. And those two terms must be completely squared of something. Otherwise, we can't apply. So 25 is a perfect square. It's square of 5. X squared is a perfect square. It's square of x. Right, write down in brackets. Okay. And minus 49 is square of 7 and y squared is square of y and whole squared. So the next step will be a plus b times a minus b. As you can see in the formula, it is a squared minus b squared must be equals to a plus b times a minus b. So I'm writing down it as a is 5x plus 7y multiplied with 5x minus 7y. When two terms are going to be squared, in between there is a negative sign. We have to multiply them and with the different signs of those numbers which are, you can say, having the roots of the given question. So basically 5 is square root of 25 and 7 is square root of 49. So I'm moving ahead to the last type of the question, which involves the common thing in the complete identity. So it can be 2x squared minus 18y squared. There is a negative sign, but we don't know whether first term is square of anything and last term is square of anything. So don't just hesitate or don't be panic or don't be confused in this. First step for the factorization is to take something common from the complete expression. So 2 must be taken as common from it. So when 2 is common inside the bracket, it will be x squared and minus 9y squared. This 2 will come at the end process as well. Don't ignore that 2. So you have to write down that 2 here. And you can see these two are squared of something. In between there is a negative sign. So we have to apply the third identity which we have discussed in the fifth part as well. So x squared is square of x and minus 9 is a perfect square. It's square of 3 and y squared is square of y. So it's a squared minus b squared. So we can apply a plus b means x plus 3y times x minus 3y. So this is all from today's video. This is about factorization by algebraic identities. I will be going to make some other videos related to factorization, but with some other processes. If you have any queries, any difficulties related to this specific topic, factorization, or any topic in algebra, or any topic in your D maths or IGCSE maths or AD maths, do let me know in the comments. I will be waiting and will be answering your queries. So it's all over from today. So stay tuned and stay blessed, and Allah Hafiz.